Well, so after all of that, we might be asking ourselves, well, that's the only trick that we know with these sum and angle formulas. We can only take the sine and cosine of some weird looking angles that we can split up as sums or differences of angles that we do know? Well, no. In fact, we've got another trick. And this is a typical kind of question that we're asked. We might be told, well, let's say we know that the cosine of u is equal to 3/5 and that the sine of v is equal to negative 4/5. And we are specifying that u is an angle that is in the first quadrant and that v is an angle that is in the fourth quadrant. We might be asked to find the sine of u plus v, or the cosine of u minus v, and the tangent of u plus v. So how do we do it? Well, this is a case where we need to do a little bit of leg work first. So let's draw some pictures. I like the pictures, and sometimes the visualization helps. So we've got angle u that is located in the first quadrant. So I'm going to draw a standard position right triangle in quadrant 1. And that's going to represent my angle u. Well, what do I know about angle u? Its cosine is 3/5, so that means my adjacent side is 3. The hypotenuse is 5 here. If I'm working this out, I can use my Pythagorean theorem to find that the opposite side would be 4. So for the angle u in that right triangle, it's a 3, 4, 5 triangle with 4 being the opposite side this time. That's useful because we're also going to want to be able to find the sine of u and the tangent of u in order to work these formulas. Let's look at angle v. Angle v is an angle in standard position such that its sine is negative 4/5. So if we were to draw this one, for angle v in standard position, we have a right triangle whose opposite side is negative 4, whose hypotenuse is 5. That means we have an adjacent side of 3 this time. So again, that's going to help us find our ratios for each of these. So let's go for sine of u plus v. We know that the sine of u plus v, and it helps me to write out these formulas each and every single time I use this formula. The sine of u plus v is exactly the same as taking the sine of u times the cosine of v and adding that to the cosine of u times the sine of v. So what are those values here from our drawing? Sine of u is going to be 4/5. If we go to our original drawing right here, sine of u is the opposite over the adjacent, over the hypotenuse, so that is 4/5. Cosine of v we're given, or cosine of v is the adjacent over the hypotenuse here in this second triangle, so that's 3/5. Cosine of u, well, we know what cosine of u is. That's 3/5. And the sine of v, we said, is negative 4/5. So let's go ahead and carry out this multiplication. We're going to get 4 times 3, that's 12, divided by 5 times 5, that's 25. And we're adding that 3 times negative 4, that's negative 12, divided by 5 times 5, that's 25. So in this particular case, we turn up with the value 0. All right, so that's the sine of u plus v. What about the cosine of u minus v? Well, we're going to go down to our bottom formula here and check that one out. Let's take the cosine of the quantity u minus v. What will we find? Well, in this quantity, remember that it is cosine of u times the cosine of v. That would be added to, we change the sign here, the sine of the angle u times the sine of the angle v. So substituting in these values right here, we're going to take the cosine of u, which we know is 3/5, that's one of the values we were given, times the cosine of v, and we found that that value was 3/5 as well. And we would be adding this to the sine of u. Well, the sine of u in this case is 4/5, positive 4 over 5. And the sine of v was negative 4 over 5 as we were given the original expression. So now we need to do a little bit of arithmetic to add these together. We've got 9/25 when we multiply numerator to numerator, denominator to denominator, added to negative 16/25. Well, combining those values together gives us negative 7/25. And so the value of the cosine of u minus v is negative 7/25. All right. Now we've got the tangent of u plus v. And this is where we're going to have to use some different values than the ones we're looking at. Well, let's see what happens here if we take tangent of u plus v. According to the formula, tangent of u plus v will be the tangent of u added to the tangent of v. And we're going to divide that by 1 minus the product of tangent of u times the tangent of v. So making the proper substitutions here, the tangent of u from our first triangle is 4/3. And the tangent of v from our second triangle right here is negative 4/3. And we're going to divide that by 1 minus the product of 4/3 times negative 4/3. But this turns out to be a lot easier than it looks, because 4/3 added to negative 4/3 is 0. And 1 minus, well, we could work this out, 16 over 9. That's actually times negative 9, right? That's a 1 plus 16 over 9. That ends up being 25 over 9, but it doesn't really matter what that means because our entire expression then is equal to 0 again. In this particular case, this is the way it turned out. They won't always turn out to be 0 or 1 or something else, as shown right here, but it is good to know that using these formulas, we can actually calculate this kind of answer. All right, another example or two to go.